I've lost my mind doing this game, yeah. Like Vincent van Gogh. He dedicated his life to his art and lost his mind in the process. That's happened to me.
Time complexity for our given solution that we have is that the time complexity is going to be constant, which is O of n, and the space complexity of O of n at the same time. The reason being of why the time complexity is O of n is that the solution requires iterating over the given array only once. Because a hash table, imagine a hash table or a map in particular, like a series of lockers to begin with, and you have a series of keys and values. What you are trying to do in particular is that you know exactly that you have one value already figured out. But then if you want to find exactly another value that's going to add up and reflect the relationship as stated before, what you would have to do is that first find in particular the relationship by creating a variable that you would then find while looping throughout the rest of the array, and finally returning both values of your hash table as well as the value of your index at the same time. And the reason why that our space complexity is O of n is that the solution utilizes a hash table to begin with to store complement values. In the worst case scenario of within the space complexity is that all elements that we have may need to be stored inside of the hash table, which is still going to be constant because it's relative to the size of the given array. And so therefore, within the fact that our solution is in constant factor for both time and space, it is already further optimized at the same time. And I don't think there can be any other iterations to further improve. It beats a lot of other times as the same point. So yeah, that was twosome for the most part. Thank you again for tuning in. If you have any other questions and such, feel free to leave them in the comment section, or if I have any other requests to solve any other problems, I'll go over them and be able to relay and communicate to you folks exactly between the series of steps. Thank you very much. Okay, and it beats a lot of other solutions at the same time, and it's also pretty efficient. Okay, so to go over the space complexity of this, since actually greedy algorithms are actually pretty efficient to start with. Our space complexity for this is going to be linear, O of 1, just given the fact that we're just scanning throughout the rest of the array to start with, because we already have our conditions already defined, such as understanding between the max profit and already knowing what the min profit is. And it's going to be linear because we don't have any data structure that we're using to be able to store exactly said information. And the time complexity is going to be constant, which is O of n, because n refers to the number of indices within the array. And depending on the expansion of said array on X amount of numbers, it's going to vary your solution is going to run slower. Therefore, the bigger the array is, the slower the type of program will be able to run. So constant is pretty good in terms of efficiency, and in terms of further optimizing this, we have optimized it pretty well, and there's no need for any other further optimization given the space and time complexity of what we have. So thank you again for tuning in. If you have any other questions at the same time, or anything else that you would like for me to go over, feel free to put them in the comment, like and subscribe, and as always, we'll see you again in the next video. Cheers. We are storing all the numbers in the array. The time complexity is going to be O of n, which is constant, which therefore the reason why it's constant is because it's relative to the n represents the size of the array. If we have more numbers in the array, the program is going to run slower. And then if the space complexity at the same time is O of n, because we are storing the elements that we've already visited inside of a set, which is a data structure that we've already called upon. And this following solution is already pretty optimal to start with, given the fact it's on constant time, and so there's really not that much improvement that we really need. And so yeah, that's just pretty much it for contains duplicate. Thank you again for watching. If you have any more questions in particular that you would like for me to go over, feel free to put them in the comment section, and as always, take care. Bye-bye. Okay, both the test cases already passed. We'll submit, and here we go. So overall, just to give a rundown on how the whole how our solution works is that our solution runs in constant time, given the fact that one, we have an array, and n represents the size of the array, and given the fact it's constant, the time complexity of our given solution is going to be with respect to the size of array. So the longer the array, the longer time it's going to take for our solution. And then in terms of space complexity, given the fact that one, we aren't calling upon any data structure to be able to actually use or store anything whatsoever. So our space complexity is going to be linear O of 1. And this is a pretty optimal solution at the same time. And yeah, thanks again. This was Max Product Subarray. If you have any questions or any comments below, feel free to put them in the comment section. And if you like this as well, feel free to like and subscribe. And as always, take care. Cheers. Thank you. Is going to be O of n, since it's revolving around the size. N represents the size of our given array, and it's going to vary based on time in constant space. And then space complexity is going to be linear of O of 1, because we are not necessarily storing any type of data structure, and we're using really just variables to start with. And so it's also relative to the size of the input, where somewhere in the retrospective constant, but really, since we're not using a data structure, the space complexity is going to be O of 1. So yeah, thank you again for taking time to be able to watch over this. If you found this helpful, feel free to like and subscribe. And if you have any questions, feel free to put them in the comment section as well. And as always, take care. Cheers. Bye. Okay, both the test cases already passed. We'll submit, and here we go. So overall, just to give a rundown on how the whole how our solution works is that our solution runs in constant time, given the fact that one, we have an array, and n represents the size of the array, and given the fact it's constant, the time complexity of our given solution is going to be with respect to the size of array. So the longer the array, the longer time it's going to take for our solution. And then in terms of space complexity, given the fact that one, we aren't calling upon any data structure to be able to actually use or store anything whatsoever. So our space complexity is going to be linear O of 1. And this is a pretty optimal solution at the same time. And yeah, thanks again. This was Max Product Subarray. If you have any questions or any comments below, feel free to put them in the comment section. And if you like this as well, feel free to like and subscribe. And as always, take care. Cheers. Thank you. Okay, and it works perfectly well. So the time complexity in particular for this is going to be O log of n, where n is referring to the length of the array, because we're essentially just doing a binary search, and the space complexity is going to be it's going to be linear of O of 1. And the reason being is because, one, we're not using a data structure to be able to assess our solution, and then two, we're just scanning through the rest of the array and make a series of comparisons to be able to declare and redeclare what are low and high endpoints. All right, and so that was finding a minimum in a rotated array. Thank you again for taking time to watch this. If you liked it, feel free to like and subscribe, and if you have any questions, feel free to put them in the comment section. And as always, take care. Have a good day. Cheers. There we go. So this is our pseudocode at the top, and this is our solution. So to give a breakdown of our space and time complexity, our time complexity, given the fact that we're doing everything in binary search, is going to be O log of n, and then our time complexity, given the fact we're not using a data structure already set in place, our space complexity is going to be O of 1 linear, given the fact we're not storing anything from our arrays, and the O log of n in particular is our time as requested from the problem, because we've already reduced the search space already from just focusing on the middle already, and we're not storing anything and calling upon a data structure. So yeah, this was search in a rotated sorted array. Thank you again for taking time to watch this. If you have any questions, feel free to put them in the comment section. And if you enjoy this video, like and subscribe. And as always, cheers. Take care. Have a good day. Bye-bye. So to go over the time and space complexity for our following solution is that given the fact that we are dealing with 2 pointers and we're not using a data structure to be able to store everything, what we were doing is just scanning the entire array. Our time, however, one of the biggest issues we're facing is that we are using a nested for loop in this case to be able to scan. So our time complexity is going to be O(n) squared, given the fact that we're using 2 arrays we're using 2 for loops to be able to run throughout the rest of the array, and then we are also trying to get 2 distinct different elements to be able to conduct our 2-pointer approach. The space complexity that we have is going to be, in our best case scenario, O log of n, and or in our worst case it's going to be constant O of n, with the reason being because it's all relative to the amount of data that is within our given array to be able to conduct exactly what our low points are and what our higher points are, as just the nature of 2-pointer. So yeah, thank you very much for taking time to be able to go over this with me. If you found this helpful, feel free to like and subscribe, and then if you have any questions, feel free to put them in the comment section. As always, take care. Cheers. Bye. Okay, so just to give a rundown on the space and time complexity for the following. The space complexity, given the fact we're just scanning over the array once and we're not doing a nested for loop, we can discern that the array, relative to the size of it, the time complexity is going to be O of n constant, because we're just focusing on the size of the array. We're not using any of the other data structure. We're instead using a technique, but we have to scan through the array, and our solution is going to run relatively slow compared with the array in constant time. And then in terms of the space complexity, given the fact we're not using a data structure to store anything, it's going to be linear as well. And so yeah, that is our solution thus far. And yeah, right over here. So this was Container with the Most Water. Thank you again for taking time to be able to watch this. If you have any questions in particular, feel free to put them in the comment section as well. That's also where I put the solution with the expanded pseudocode. If you have any other requests or questions as well, put them in the comment section. And if you enjoyed this, like and subscribe. And thanks again. Cheers. Bye-bye.